Hey there, Fawa. I did not get a chance to send out an announcement yet for today's class, but it's good that most of you are figuring out all you got to do is show up here at 4 o'clock. So good. All righty, so guess what I figured out? How to get the VPN working. Got a couple of things I want to show you today. So I figured out how to get the VPN working so that we are able to, let me disconnect from this. I want to show you guys this first, okay? Okay, and I'm recording this, so for those of you that are not watching this synchronously today, that's fine. How you guys doing today?
Doing good.
Good, good, good. Hope you're learning stuff. Was anybody successful in getting VirtualBox running and trying it out that way?
I got it up until like it asked for a username and a password. I wasn't able to get that, but I got it to like sync with CentOS.
Okay, good, good. So, and I finally got it running too. What I had to do is I had to reboot my laptop, and this is because I wanted to get the 64-bit version running. I had to reboot my laptop and go into the BIOS and enable virtual technology, or what's called VT technology. I don't know why, or I didn't know why it wasn't automatically enabled. You know, most laptops these days and most workstations these days have what's called VT or virtual technology or hyper threading capable in the chips, like the Intel Core i5 and up, the 7th generation and up, is able to do what's called hyper threading. And that's what you need if you're using a true virtual environment hypervisor. The older versions of VirtualBox before 6.1, it was an option. You could tell VirtualBox to run guest machines or guest hosts on your machine, but they weren't going to run very efficiently, and it was not going to run well on your computer unless you had VT technology enabled. But now it looks like they've decided, you know what, we're far enough along in our evolution of computers to where we can assume everybody has VT capability. However, for whatever reason, they decide they don't want to enable it. They don't want to enable it in by default. They claim that it is a excuse me. They claim that it's a security issue. I don't know how it is a security issue, but apparently it's a security issue. So anyway, let me share my screen here. And now I've got hyperthreading running. I was able to get VirtualBox running. I downloaded a 64-bit, the i686. And so, by the way, when you're searching around, if you even want to do this in VirtualBox, I know I suggested it, and I think it's a good idea, but it's not a requirement of the class because I'm going to give you a Proxmox environment. It is good practice and good study, and it's good to know it. But understand this first. If you see anything that says i386, Symptos blah, 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 i386, Debian blah, 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 i386, that equals a 32-bit OS. Okay? If you see anything that says i686 or AMD, that equals a 64-bit operating system. All 64-bit operating systems that are used in computers are considered to be called AMD now, and that's because Intel finally had to admit to AMD, Advanced Micro Devices, that they invented the 64-bit processor. So i686 is no longer synonymous with Intel 686. It's called AMD now. So you're either going to see something called I686 or 86 like that, or AMD. That's referring to a 64-bit processor. As long as you've got a fairly modern computer, you should be able to download and run 64-bit OSs, 64-bit apps on top of that. In order to run a 64-bit app, it has to be a 64-bit OS. A 64-bit OS can run 32-bit apps. And as I mentioned in the last class, the only difference between a 64-bit and a 32-bit application is how much total memory it can access and how much hard drive space it can access. A 32-bit computer can't access larger than a 2 terabyte hard drive and no more than 4 gigs of RAM. So if your computer, as is in the case of my laptop, which I'm using here, has more than 4 gigs of RAM and it was an only 32-bit computer, it would only show me 4. It would say 8 gigs installed, only 4 gigs are usable. So anyway, you'll notice that my little laptop here, and it's not that powerful of a laptop, it's pretty good. I've got a total of 4 processors. There's 1 physical socket. So keep in mind these terms, because these are terms you probably should know for the future too, or for the now. Socket refers to the physical plug on the motherboard of your computer or your server. Most servers that live out on the internet have 2 sockets or 4 sockets. They don't all have just 1 socket. Most of your laptops and most of your workstations have 1 socket. 2 cores means there's literally, stuck within that socket, there's literally 2, if you were to break open the chip, 2 sets of processor chips in there. Now the reason that this says that there are 4 logical processors is because the Intel i5, I thought this was an i7, it's an i5 laptop, actually does what's called multi-threading. Okay, so let's throw these terms up because these are terms you need to know, need to learn. Sockets, cores, and number of threads. Okay, sockets refers to the physical plug on the motherboard. The core refers to the actual amount of Intel chips or AMD chips that's built within what's called a package. It used to be a chip that you put on a motherboard, like a little square chip, was 1 processor. But now a chip is really a chipset, that big square that you see. Has anybody ever bought a processor and put a processor on a motherboard before, by the way? Most of you probably have not, but maybe some of you have built your own computer. So it looks like Robert has. That chip that you buy, let's see if I can find a picture of one just real quick. No, there's one over there. So these chips, that's not just 1 chip. Flip the chip over and look at the bottom of it, and there's actually a lot of stuff you don't see. Each of these little bits here makes it's multiple chips in there. There might be 15 or 20 chips on there, which create a processor set. So what this really is this is a package. This is a package of 1 or more processors. So the number of actual physical processing units, like little miniature computers, on this chipset is referred to as the number of cores. Most of your laptop computers and your desktop computers are dual core or quad core. So you see the dual core or quad core. In servers that they put in data centers, they are hexacore or 8-core, or even, I think the highest right now is 12 or 16 core. In 1 socket. That's like having 16 computers in the space of 1 computer chip. Furthermore, there's a thing called thread. If your processor is what's called multi-threading or hyper-threading, that means that 1 processor, that 1 core, can run multiple instances of code at the same time, almost at the same time. What it does is it interleaves, it's called interleaving, it interleaves processes. So if you want to run 2 programs at one time or 2 processes at one time, you could run both of those processes and they'll look like they're running at one time on one core, because if your core is hyper-threaded, it might mean it can actually run 2 things at one time. It runs one instruction from one program and then puts that aside, and then runs another instruction from another program, puts that one aside, and it keeps switching back and forth. It can do this so fast that it looks like it's operating as 2 cores. It would be kind of like me talking to you and me having another class, another video at the very same time with another set of students, and I'm so fast that I can say a word here, then say a word there, then here, then there, and jump back and forth so fast that you can't tell. If I could jump back and forth between 2 different video streams at 24 times per second, that's fast enough to look like I'm only talking to you. If I can jump back and forth 48 times, and if I was that, I'm not a computer, but computers can do that. They can jump back and forth 48 million times per second, so it looks like they're doing multiple things at one time. So hyper-threading processors can run either 2 or 4 or even 8 threads at one time. So what this tells me on my laptop, and this is the number that you're really concerned about. That's all you're really concerned about is logical processors. How many logical things can be running at one time that are separate from each other? So this says 4, and that's because the core, the chipsets that are in these, can actually run 2 processes at one time. So that's 1 socket times 2 cores times 2 processes. I get 4. Some of my servers I have running, there's 2 sockets, quad core processors, and 4 processes at one time per core. So that's 16 processors. Some do 32, some do. I set up one recently for a client that does 64 processes at one time between 2 sets of chips. Pretty good stuff. With true virtual technology, if your hypervisor is aware that you have a multi-core processor, you can dedicate one specific core, one specific logical processor to that one VM, and it'll run a lot faster. Otherwise, what will have to happen is it interleaves the VMs in a pseudo virtual environment, so things get a little bit slow. But that's all I wanted to point out about that. In Proxmox, when you're building virtual machines, it asks you, how many cores and how many sockets would you like to allocate to this virtual machine? Usually I just tell you to choose the default of 1. All that is it's a relative number. You can't choose more than the number of cores and processors that you have. So in my little laptop here, I've got 4 cores. If I try to build a virtual machine in VirtualBox, or if I was running Proxmox on this machine, and I said, give it 8 cores or 8 processors, it's going to say that's an error. You can't do that. And what it really does is it sets a relative value for that process. If I set 2 or 3 other virtual machines on my computer to run with 1 core or 1 logical processor, and then I have one of them that I need to give more deference to, more power to, I'll say that one has 2 logical processes, and then your hypervisor will run it at twice the speed as all the other processes. So occasionally, when we're setting up virtual machines, what I'll tell you to do is start out building your virtual machine with 2 cores. And start it out with more memory than you probably need, like 2048 megs, which equals 2 gigs of RAM. Just to get it built and installed, because when we're installing software and we're compiling software from source code, which we will be doing later on in the class, that might take 20, 30 minutes sometimes to compile. Once it's compiled and it's in what's called object code, then we can go back, turn the virtual machine off, and pare that down and say, look, I'm just going to run with 1 core and change that down to 1024 or 1 gig of RAM, because that's all it really needs to run properly, okay? And that's the only reason that I'm pointing that kind of technical stuff out. Okay, so I'm not going to show you right now any more about VirtualBox, but what I am going to show you, and this might be a little bit repetitive for those that are in my 4477 class at the same time, because I just showed people how to do this, but I'm going to show you how to log into the EI Lab via VPN. There are several different types of VPN. First of all, does everybody know what VPN stands for and what it is? VPN. What is VPN? First of all, does everybody understand that most networks that you're operating on, most LANs that you're operating on, are internal and private, and the data that's floating around on those LANs and the IP address that you're using is not a publicly addressable IP address. So there's only two ways to access workstations and servers inside of a LAN that are behind a firewall. A firewall is a special purpose device on a LAN that connects a LAN to another LAN, or usually the internet. It has at minimum 2 network connections, as in the case of the SonicWall firewall that I use here. Let's see if I can log into it. I wasn't able to earlier because I was logged in remotely from somewhere else on it. Otherwise, I'll show you another one. Okay, so I was logged in somewhere else and eventually got kicked off. Okay, so in this SonicWall, this is a relatively high-end firewall. It has multiple network connections. Virtual something, it stands, by the way, VPN stands for, let's back up for a minute, Virtual Private Networking. And we use it because we use firewalls. We use a firewall because we want to protect our LAN from the rest of the internet. We want a private and a public internet. In other words, if you wanted to protect people in your home, you would not let them go outside. You would keep them inside. They would say, well, you know, I need to eat and I need to talk to people in the outside world. You, as the manager of the home, or the firewall, or the bouncer at the door, would say, tell me what you want, I will go get it for you. Or tell me what you want to say, I will say it for you to somebody standing outside the door, and then I'll relay their messages back. That's kind of like what a firewall is doing. That's very important for local area networks and workstations, because people's computers are now so complex that they are vulnerable. End users can accidentally install code on their computer that it's okay if the local people on the local network see that computer or share that code, but it's not okay if somebody in the outside world uses it. So for the past 20 years or so, most local area networks are private. So actually, before I talk any more about firewall, let me point this out. I talk about this in 4477. There are a range of private IPs, and this is important for you to know so that you can conceptually get this VPN working. There are 3 ranges of private IP addresses, and I guarantee everybody in here communicating in this Zoom meeting, if you were to go check what your IP address was, you go check that various different ways. I'm going to go in a network sharing center on my computer and just check and see what the details are of this connection. This connection's IP version 4 address right here is 172.17.227.164. That does fall within that range of 20-bit network numbers, which are considered to be internal. So you guys at home, or wherever you are, is everybody at home? Anybody access the class from somewhere other than a home, or do you have to go to Starbucks or something? Or an office? So if you're all at home, you're probably using, I'm going to guess, Xfinity or AT&T. So you're either on a 192.168.0 or .1 network, or you're on a 10.1.10 or 10.0.0 something network. Those are internal. You're actually communicating through a firewall. Usually Xfinity or AT&T provides it to you, or you went out and bought your own, but usually they provide it to you. And it has two connections. So it's got an internal number, internal physical connection. Usually it's 4 ports on the back of a box, and then you've got one external WAN port. They usually call it the WAN port. They're usually color coded too. Yellow is the WAN port, and blue or black are the LAN ports. The WAN port has a different IP number, which is assigned by your internet provider. When you turned it on, it automatically assigns that, but that's going to be some public number because of this. And so now getting back to the VPN, because we use firewalls to protect our local networks, there's only 2 ways to get into that LAN. And I have a firewall here that protects all the servers that I'm sitting next to. There's all the servers are sitting in these data racks that you see back there. I'll show you some pictures of those later on. But even my servers are not public, and that's because the servers should be protected as well. So 2 ways to get access to them. Either you have to run special software on the server, which basically sends its screen and keyboard information to another device which can publicly be accessed on the internet. Or you actually do put your server on the public internet by giving it a real IP address, which we don't recommend. Or if you as an end user or a user on another network, if you're not on this LAN, in other words, if you're not back here in the EI lab, you can't talk to these servers. And since nobody's allowed this semester into the EI lab, you need some way to physically or virtually be here. So short of setting up remote access software on all of these virtual Windows 10 workstations, which I'm building for you, that's a lot of work, so I'm not going to do that. I'm going to set up VPN for you. With VPN, you're basically making a connection between your laptop and my network here in the EI lab, so your laptop appears to be on my network. Okay, so I have programmed the SonicWall firewall already with VPN information. Let me just show you a couple things in this firewall. This is interesting information. So this, let's see, boy, I haven't used this in a while. So I'll go to network interfaces here, and I'll just show you that this computer has multiple interfaces. All of these things called X something, these are physical ports on the box. X1 has been configured as a WAN interface. So that number right there, remember that number, write that down. I'll write it down right here. That is the public IP address of my Sophos firewall, and you're going to need to know that. Now, in some cases, those are actually named with DNS information, but I don't think it's DNS named, so you need to know that. I know that looks like a private number, but it's just a coincidence. If you were to take that number, or any IP number, by the way, and if you want to know who it belongs to, you can use a site like Aaron.net. You can search for an IP address, and it will tell you who it belongs to. You can do this with your own public IP address. You go to ipchicken.com or ipmonkey.com in a browser, see what it tells you. Plug that in at Aaron.net, and it'll tell you what internet company that IP address belongs to. In this case, this range is 192.138.194. Look, it belongs to U of H. It specifically belongs to the Bauer College of Business, or the RICS department here. In other words, it's my Class C to use with. I get a piece of it, not all of it. I get a piece of it. I get like 5 IPs to use however I want. So Aaron.net, very, very good tool to use. Excuse me. flip the light off and back on. By the way, I'm not using a virtual background today because I'm wearing a shirt the same color as my green screen. So when I turned it on earlier, suddenly I had a bunch of, it was weird looking. It was just me, a floating head. You guys want me to be a floating head today? I don't mind, I'll be a floating head. Blow that up. Anyway, back to this. Oh, I turned off the video and back on real quick. Sorry about that. Okay, so you guys can still see the screen or no? Still seeing the screen? Okay, good. All right, so that's the first piece of information that you need. And this is in my notes. I put this in the announcements for today, by the way. That's the first piece you need for VPN. The second piece you need is what's called the pre-shared key. Now, there's a few different ways to do VPN. One of them is to specify an individual username and password for everybody, which you do need that when you're logging into the domain controller, which is here in the lab. But just for setting up the VPN, I thought, let's just use a generic shared, pre-shared key. So for this semester only, I made the pre-shared key DISC 2020. DISC is what our department used to be called, the Decision in Information Sciences College. I think that's what that stands for. Now we call it MIS, but it used to be called DISC. So DISC 2020, that's your pre-shared key. That's the next thing you need. Now for future reference, your username and password, and you can go ahead and use this. In fact, I want you to use a username and a password for your VPN so that I can keep track of who's using the VPN. Your username is going to be your student ID. Okay, so I have a sample student ID profile. I've set it up with 7 zeros, 1, 2, 3, 4, 5, 6, 7, and I've set up a particular password, which I'm not going to tell you. And I'll send everybody an email. I will send you a password that you're going to use so that by this weekend, I'm going to commit to getting that done by this weekend, so that sometime this weekend you can try doing this. But you could try the VPN part now. You don't have to have your student ID and your password set up yet, just to try the VPN tunnel. So like I said, there's a couple of other ways to do VPN. This particular way using a pre-shared key is called L2TP. That happens to stand for Layer 2 Tunneling Protocol. Okay, there's another one called PPTP, Point-to-Point Tunneling Protocol. It's older, not as secure. There's a newer one called IPsec. It's more secure. Cisco has their own flavor. And then there's a couple of other flavors of VPN that have been developed in-house by other companies. But really, these are the only three that you see out there. It's either going to be IPsec, Point-to-Point Tunneling Protocol, or L2TP. Okay, we are going to use L2TP. Okay, now first of all, I'm going to make sure that I'm not connected to a VPN. So I'm going to check my network and sharing center here. Oh, excuse me, not that. And I don't know how to get to this in a Mac, but I'm sure you can Google for this to find out what your network connections are. Change adapter settings. You'll notice I've got a lot of adapters, and that's because several of these are really VPN adapters. I've got a Bluetooth adapter in my computer. I've got an actual local, an actual Ethernet connection. Now these two things are kind of the same thing. This is married to whatever adapter is actually using the LAN at the time. And then I've got this one. That's a VPN. That's a VPN. That's a VPN. Here's the one I'm actually using right now. I'm using Wi-Fi. I'm talking to you on my laptop here via Wi-Fi. Here's how to set up a VPN connection. Now, first of all, like I said, I've already set up VPN in the firewall. So let's go take a look. And this is going to be different depending on what brand of firewall you're using. SonicWall is a very, very common one. I created a WAN firewall group, a base setting, not firewall, excuse me, a VPN grouping. And I said that I want to use the authentication method of what's called IKE using a pre-shared key. Okay, so that's where I told it, I want to use just this single disk 2020. That's not the best way to do it, by the way, not very secure, because I have to share it with everybody. The best way to do this is make it so that it authenticates off of a domain controller with a username and password that an individual user can change, kind of like how you do the Wi-Fi at U of H. L2TP server. Oh, this guy's connected. I'm going to disconnect him, by the way. I must be running it somewhere. Let me disconnect it. Okay, there we go. So let me show you how I configured this L2TP server. So I said I needed to specify a domain controller and DNS server somewhere on my local network. So that IP address, by the way, is the domain controller here in the EI lab. You will need to know that. Not necessarily for today, but you will need to know that for future reference, because that's the machine that you're going to talk to when you're talking to the domain. Is at 192.168.1.31. Okay? So keep that in mind. I also specified a secondary DNS server, which is 8.8.8.8. Does anybody recognize that number? Other than it's good luck in Chinese. That happens to be one of Google's public DNS servers. The Win server, or the Windows domain, Windows domains are a little bit different than internet domains, is also the same thing. And then I actually have I have two domain controllers running here. One's a backup domain controller. That's the IP address of the backup. So I put that in there. Then I set up users here. I said, I want to use just that pre-shared key, but I'm going to create a pool of IP addresses that are going to be assigned to each one of you as you log in. So right now you have a unique IP address that's assigned to your local connection. If I go back to my network connections here, my wireless connection, if I were to ask for the status of this connection, that IP version 4 address right there is the number that I'm using to communicate with my local network. Once I enable the VPN tunnel, once I set it up, I will see one of these connections. We'll use this one here. I set it up there. It will have a new number associated with it. And that new number is going to be, where'd that window go? Excuse me, lost it. There it is. That new number is going to be 192.168.9. something. And that's because your computer needs a unique number to communicate across the VPN. It's like giving your cell phone two different numbers so that the world can call you and then this private company can call you on a secret number. So this is just a randomly assigned group. So obviously there's a range of 90 addresses there. I don't have more than 90 students this semester. So this works just like DHCP. It's just going to randomly hand out an IP address. I'm not using PPP. So that's kind of what I do in the background there. And then I've got the authentication set up to disk 2020. I set that up somewhere else. So let's go to monitoring here. And I'm going to just sit on this screen because I'm going to watch I want to see if any of you guys log in while I'm doing this. Okay, so here's what you do on your laptop or your desktop computer to set this up. Now, this is the Windows way to do it. If you have Mac OS, you're going to have to go Google for this. I sent a link in the, I sent a link to the 4477 class, not 4397, but basically what I Googled for is I Googled for how to L2TP, I specified that, VPN Mac OS. And I looked for something that looked like it was telling me what to do. Let's try that one. shared secret, that's the same thing as pre-shared key. So all the same elements are essentially here, which is what I'm about to show you. You have to have a server address, an IP name, a username and a password, and this pre-shared key. And then you have to specify the type of VPN, which is L2TP, because I've told you. We're not doing it over IPsec. We're using L2TP with pre-shared key. That's the difference. Okay, so in Windows, here's how we do that. We go to our network connections, and you can get to that a few different ways, but I just get to it by typing in the word network in Windows 10. Here's Network and Sharing Center. I click on that, brings up this screen. I'm going to click on Set Up a New Connection or Network. Now, I've already got several set up, but I'll just set up another one. Set up a new network. This screen pops up. Connect to the internet? Nope, I'm already connected to the internet. Set up a new network? No, I don't want to do that. Manually connect to a wireless network? Nope. I want to do this. Connect to a workplace. That's what we use VPN for most of the time. Connecting to a workplace server. So I'll click on that, and it even says the word VPN right there. This is fairly easy, I think. It's much easier than getting VirtualBox running, especially since I haven't installed VirtualBox on a PC in 4 years. Should have done that before I had that class last time. Oh, and I will post that video, and a lot of that video is me sitting around staring at the computer, but if you fast forward and I start talking, you'll see the screen. I did get it working. If you guys want to see what little couple mistakes I made to get it working. There's already 3 there, but I'm going to create a new connection. I'll click Next. Use my internet connection. So I'm going to click on that one. Internet address. That's where I type in the address of the server, 192.138. Not the domain controller, the firewall. 194.45. Destination name it whatever you want. I'm going to call this EI Lab VPN for 4397, just so that I can differentiate it from the other ones I've set up. Remember my credentials, allow other people to use this connection. Now, if you click that, that's an interesting thing. But if you do that, then you can tell your computer on your local network to act as a firewall, as a gateway for any other computers on your network, if you wanted to, and tunnel all that traffic through to the EI Lab. I don't want you to do that. You don't need to do that, so just leave that off, okay? Now we're going to click Create, and this is all we're doing on this page. We're just specifying the server number or the server name. Click Create. I haven't connected yet. I've just created the basic setup. Now I'm going to go to the new adapter that gets created. Change adapter settings. There it is. It's the one that I just created. So it will pop up on your screen. Right click and go to Properties. Don't try connecting yet because we have to change some things. Go to Properties and go to Options first. So there's the general properties. Go to Options. Remember my credentials. Yes, let's leave that on. Change this to something meaningful, like maybe 20 minutes of idle time. I don't want you sitting on my firewall with a VPN connection on when you're not using it, so don't leave it on forever or never. This will not kick you off after 20 minutes. This will kick you off after there's 20 minutes of no packets going back and forth from your network to mine. Okay, in fact, I'm going to set mine down to 10 minutes just because I want it to time out intentionally faster. Okay, then I'm going to click on Security. This is where we choose the security type. By default, Microsoft sticks in automatic, and it will try all 3 or all 4 of the security VPN types, but that takes a long time. So let's just tell it, I want layer 2 tunneling protocol with IPsec right there. So choose that. Then I'm going to go to Advanced Settings. Click on Advanced Settings. I don't want to do that. Use a certificate for authentication. I don't have a certificate published on the internet. The only way that would work is if I had published that IP address as having a valid certificate somewhere on the internet that a certificate authority like Network Solutions or GoDaddy had information on. you do this, people that run websites that want a secure shell or a secure website, like HTTPS, they apply for a certificate, a public certificate, but you have to pay money for that. So I don't have a certificate, so we're just going to use pre-shared key. Not as secure because I have to give it to you, whereas in the case of a certificate, your computer will automatically go out and find, hey, is there a certificate, is there a key in the world that matches 192.138.194.45? And if there is, it gets downloaded to your computer. It's a big, long-ass number, stored in your computer in a secret place that you can't see. So that's the more secure way to do that. Pre-shared key, disk 2020. So type in disk 2020 there. Click OK. Let's go to networking. And you don't need to change anything else at this point. So all four of those things are checked already. You don't need IP version 6 because we're probably not going to use IP version 6, but you can just go ahead and leave all four of those checked. At the very least, you need IP version 4 checked. Okay. You can click on properties of this and you can see that this looks a little bit like when you're setting up local area network, if you've ever done this. You can't specify your own IP and need to let my server give you an IP address. So leave these two like that. General options. PPP settings. I don't think we need to change anything there. Yeah, we don't need to change anything there. Security, networking. I don't think we need to change anything there. Sharing. Again, we don't need to do anything there. Let's click OK. Okay, so now I'm going to connect to my SonicWall. And I want to show this at the same time so you can see it connected. Double click on that. Here's, which one did I just set up? Oh, there it is. That's the one I just set up, okay? I'm going to click on advanced options from right here. And the only thing that I'm doing from the advanced options here is I'm going to click on edit because I want to enter. I'm going to enter the pre-shared key again just to make sure. It should be already in there, but I'm just going to add it again right here. DISC2020. Get this there. And then I'm also going to put in a username and a password, even though it says it's optional. I want to keep track of it. So use your username, use your student ID. 1, 2, 3, 4, 5, 6, 7. Now, you don't know what your password is yet. It doesn't matter what it is right now. So just leave it blank for right now. Make sure that checkbox is on. Click Save. So we should be done. I'm going to back up. Now I'm going to double click it or single click it and then click Connect. Connecting to the EILab VPN. Hopefully this will work if I didn't make a mistake. If I did make a mistake, I'll use one of these others I already set up. Should have connected by now. I must have made a mistake. Let me try this one. Yeah, let me see what mistake did I make. (192.138.194.45) L2TP with pre-shared key, username and password. It looks like it should have worked. I don't think I made a typo there. I did this one in the previous class. Let's look at its options to see if there's anything different. I don't think there is. I think it's all the same. DISC2020, username and password. Save. Back up. Let me log back into the SonicWall. It timed out, so let me log back into it. And I would like somebody, if you're doing this, I'd like you to try it at the same time just to make sure that we can get multiples in at the same time. Connect, completing the connection. This might take a little bit of a time, but eventually this will complete. Why did that time me out? Oh, you know why it timed me out? Because now I'm living on a different network. That means that's actually a good thing. I'm living on a different network now. Should see myself pump up in a minute there. Connected. Here I am under active users. Oh, it's because I'm not using SSL VPN. So under active users here. Oh, I'm actually logged in twice. I must be logged in from another computer somewhere else. So I'm actually connected in from 2 different computers, probably from my one here on my desk, using L2TP. Notice that IP address there, 192.168.9.15 and 9.17. So I got 2 IP addresses connected in. That 129.7.121.76, that's the public IP address I'm coming in from. That's your ipchicken.com. Oh, I see what's going on here. Windows is asking me to sign in. I'm not going to sign into Windows right now. I don't need to. That's why that one stopped. Turn that one off. I don't need both of those. I just need one. So let's see. Here's a good test to see if this worked. Okay. How can I test to see if this worked? Oh, I know. I'll open it. Oh, I got a command line open. Let's try pinging something on the local network. Let's try pinging the DNS server. Ping. Has everybody heard of the ping command, by the way? And do you know how to open a command prompt? On Mac, they call this the terminal. Username and password combination is not recognized. Okay, I'll check that out when I'm building it. It's probably because I have not yet added. I've only added myself. I have to add all these usernames, your student IDs to the domain controller. If you leave the username and password blank, or if you just make it all zeros for right now, it will work. So just leave username and password blank for right now, but you definitely need the pre-shared key, okay? So let me try pinging the domain controller, which is at 192.168.1.31. And I can ping it. So that tells me that I am now communicating on an internal network. Here's another thing I can do that will also prove I'm no longer myself, I'm somebody else. Let's go to ipchicken.com or ipmonkey.com. There's a few that you can go to. And it is telling me, hey, you're no longer at the Xfinity IP you were at before. So here's what you could do as an experiment. Do ipchicken.com first, then establish a VPN connection, then go run ipchicken again, and you should see that IP address. So now you're no longer using your local network, or you sort of are. You're using your local network simply as a road to get your data to my firewall first, and then it's all going out from there. If you wanted to use another command like traceroute, trace RT, let's see what the path that our packets are taking to get to somewhere popular like ESPN.com. So traceroute -D for don't look up the domain names, ESPN.com. Let's see the path that my data is taking. So you should note that your data is going from your public IP to a private internal IP address. You might get a few request timeouts here, and then it'll go back out on the internet on some public IPs in just a minute. Just wait here. We have a couple of firewalls that intentionally don't respond to ping and traceroute. So here we are. Now we're back on the outside. So we went into the network and then we came back out. So that's why we're seeing that 172.16 4 times there. And then eventually we'll hit some firewall or some server at ESPN.com. The reason I mentioned that one is because that's a very, very super busy network. It's the same thing as the ABC network and the Disney network and the Go network. Those are all those companies. For those of you that did not know that, ESPN, Disney, ABC, and Go are all owned by the same rich people in the world. This will probably time out. This will probably never complete because ESPN probably doesn't respond past a certain level of firewalls. If we trace her out to the Google public domain, public DNS server, that should and will work because it's a public DNS server. It has to respond to what's called ICMP. Okay, so yeah, let's just wait for this to finish. Or actually, while that's finishing, let me show you something else that's kind of neat. So now, from this point forward, you could pretend you're in the EI lab and actually do the first EI lab assignment, which is set up your virtual machine. Now, as I said, I don't have your Windows virtual machines available yet because I want to set up Windows 10 virtual machines, which I'm going to do right after class, but right now they're all Windows 7. And I think I just want to abandon those and create some Windows 10 machines for you. Okay, so eventually that finished. If I turn that off, if I turned off the VPN and then did this again, it would take a different path. eilab.bauer.uh.edu. Now, if I were to type that in my web browser, here, I'll do it in Chrome here. eilab.bauer.uh.edu. If I were to do that without being connected to the VPN, it's going to give you an error and it's not going to work. It's going to say, I don't know what EI Lab is. Oh, excuse me. It doesn't know what EI Blah is either. Now that, by the way, that's what you get if you go to some non-existent domain name in the EI Lab. You get that IIS7. In order to use what's called the Citrix Zen desktop to remotely view your computers, you're going to need Chrome first of all. So everybody needs to download Google Chrome. And then you need to also install within Chrome something called the IE tab. This is so that legacy websites that are designed for Internet Explorer will display properly. So install that as well. It's just a plugin for Chrome. I've already plugged it in, so I don't want to remove it, but it's there. And then you get this little icon up here. We're going to have this one, the Chrome Remote. Have I showed you guys how to use Chrome Remote yet? Anybody using Chrome Remote yet? No? Okay. I may go ahead and do that today, but once you set up IE tab, you'll get this little extra icon up here next to your picture that you can click on, and it makes your Google Chrome look like Internet Explorer. Then you can do the name of the server. This is in my notes for setting up your workstation. There's a specific server that you want to go to. It's called the Zen server, zen.eilab.bauer.uh.edu. The Citrix Zen server is one virtual machine server that's running in the lab. So we're going to go there using my IE tab. That screen right there. That's what you see. And for those of you that took 4477 before, that looks familiar, right? Is there anybody in here that took 4477 before? Probably not. Only got 6 of you participating, it looks like right now. But I promise you that's what it looked like before. If you were to go into the EI Lab, sit down to one of the workstations in there, the screen looks just like this. your login is going to be, the username is going to be your student ID. So this is where your domain name is important. So that's my little sample. And then the password is whatever password I assign you in an email that you're going to get a little bit later. I'll just indicate it by that. And then the domain, you do need to specify the domain here, eilab.bauer.uh.edu. Those are the three things that you need right there once you get to this part. So username, 1, 2, 3, 4, 5, 6, 7, password. And you realize right now, we're not running a virtual machine yet. This program, this Citrix Zen desktop web page, this is running on your local machine. If, by the way, a little green button pops up and says you need to install the Citrix viewer, go ahead and install it. It's a little simple viewer that you need to install. Password. Already set a password for this one. And then the domain, eilab.bauer.uh.edu. Log in. You'll get this screen, Student VM. As soon as you click on that start button, it's going to fire up a virtual machine for you. Right now, I've just got Windows 7 virtual machines on, so I'm going to click on that. And it's going to probably pop up in a separate window. There it goes. Eventually, this will redraw itself as a Windows 7 window. Now, the very first time that you guys go in, once I've set these up, it's going to take maybe a couple of minutes because these are virtual machines that I just created and they will be off, just like your laptop or your desktop computer is off and you're pushing the start button for the first time. So what you're going to see is this will be swirling around. You're going to click that and you're going to see swirling, swirling, swirling for a couple of minutes. Finally, and depending on how many of you are logged in at one time, finally it should show you that screen. You should get a login, and you can make sure, you need to make sure that this is your virtual machine and not your machine. Okay, so there's my start button down there. There's the start button of this Windows 7 machine. You can click on that and make sure that you're logged in as your student name, or you can go down here to computer. In the case of Windows 10, it's called This PC. That's what you'll see on the screen. Right-click that and go to Properties, and it'll tell you your student machine number, the computer name right here. It's going to assign you a random number from 1 to 100, or 1 to 99, I should say. I happen to have gotten student machine 43. Now, once a machine gets assigned to you, it's going to be the same throughout the entire semester. So the Zen desktop randomly assigned me machine 43, so that's what I'm going to get for the whole semester. If you get 42, that's what you're going to get for the whole semester. Virtual machine 42. That way, you can install whatever code you want on here, whatever apps you want on here, and you'll be able to pick up where you left off. You're not going to get some random machine every time. So these are not like lab computers, where you're sitting down to a lab computer, you log into a Windows domain account, and then you have access to generic tools, or maybe you log into Chrome and you can access some of your Chrome apps, but then you have to be sure to log off, and you have to be very secure and make sure that you don't, and you can't install software on the lab computers. You can install software on these. You are the admin user for these computers. If you go to the control panel, and this is a little different in Windows 10, but you can find all the same thing. The user account, this student user account, is the admin for this machine. Now there is an eilab user. Okay, so this is you. So you're the admin. You can install whatever you want on there. You can break it if you want. I don't want you to break it. I'll have to turn it back on. Things to remember when you get to this point, which is hopefully sometime this weekend. Things to remember. Do not log out of this machine, or you can log out, but if you log out of the machine and you go log, click on the start button, you click log out, it literally puts that machine into hibernation, that virtual machine into hibernation. The only way to unhibernate it is to go back into the Zen desktop, push that play button again, and it's going to take a couple minutes to turn itself back on. So I recommend that rather than doing a log out, just leave it running and just click the X up here, or you'll notice there's a little bar up here at the top. This is true for all remote viewing programs, whether it's Chrome Remote or TeamViewer or GoToMeeting or GoToMyPC. You all have some sort of a bar either at the top or at the side that allows you to do things like disconnect from the machine, reboot it, go to full screen, change some preferences. I can, scale to fit, or I can do actual size or best resolution, or use multiple screens if I wanted. I can turn on a webcam if I wanted. Several things that you can do with the Zen desktop. But I don't recommend logging out. You have the Control-Delete button. That's important because sometimes you need to press Control-Delete to reboot a virtual machine. But if you press Control-Delete on your laptop computer keyboard, what will that do? It will be interpreted locally, and you'll end up rebooting your local computer. So do not press Control-Delete. If you want to have that translated in the local, in the remote machine, do that. Okay. Do not shut the computer down. If you shut it down, how are you supposed to turn it back on? It will not turn itself back on because you shut it down. There is no on-off switch on a virtual machine. The on-off switch is me logging into the admin panel to then virtually turn it back on. And I can do that if you email me or text me and say, hey, I accidentally shut my machine down, or it crashed, or something happened. Sometimes I have to reset machines, but it's not going to be very fast because I might not be available at the time, or it might be 2 in the morning. Please don't text me at 2 in the morning unless it's really, really important. Like, like if you're having a mental breakdown or whatever, feel free to text me at 2 in the morning. But hopefully nobody's going to get to that point during the semester. I have had students in the past that just were freaking out because a lot of this stuff is completely foreign, completely different. You've never dealt with virtual technology before, and this particular class is very, it's not very structured. It's very open. It's very interpreted, and that's because I treat it like a research class where you're conducting experiments, and not everybody's experiments come to fruition. They don't all prove to work. I might ask one student to do something different than another student, or one team to do something different. So I don't want you guys getting into weird situations where you feel like you got to drop the class, or there's no way you can pass. Most people pass this class just fine. A's and B's. That's almost all I ever give out in this class. So once you get to this point, I recommend that you install one very useful piece of software. You're not, well, actually 2 very useful pieces of software. Chrome will not be already on there. In the case of Windows 7, you get Internet Explorer, which you don't see because I took it off the menu, but you get, let's see, IX. So yours will have Internet Explorer on there. So you can that's the only browser. Or in the case of Windows 10, it's Edge. So you're going to have to open up Windows Internet Explorer or Windows Edge, one of those two. I don't want you to use either one of those browsers because those are not really industry standards. You may go to work for a company which says you got to use Edge or Internet Explorer, but those are few and far between. Unless you go to work for Microsoft, you're probably going to be using either Chrome or Firefox, or maybe Opera, but it's usually going to be Chrome or Firefox. So you're going to open up Internet Explorer and you're going to go to google.com, or you're going to go look for download Chrome. And you're going to download and you're going to install the Chrome browser. Would you like? No, screw you, no. You're going to go down, and now when you Bing something, the first thing that pops up when you try to Google for any other browser, the first thing that Microsoft pops up is, hey, try Edge, please. Please don't leave us. We love you. This is better, we promise. Has anybody used Edge yet? Microsoft, I used it a little bit. It's not as heavy as Internet Explorer. It works better, but it's not Chrome, okay? We all love Chrome now because it's Google, it's not Microsoft. That's one. So they're begging you, please download this instead. Skip that and go get Google Chrome. Go get the real tool. Go get the Ferrari. Leave the Volkswagen behind to get the Ferrari, okay? So you're going to go download that. I'm not going to re-download it because I've already downloaded it. But go download and install that. If you don't have a Chrome account, a Google account, please go sign up for one, okay? You need a Chrome account just to operate in this world these days, okay? Okay. Once you've got Chrome installed, go log in with your Google user. So I'm going to run Chrome here. And this is true whether this is 7 or 10. So there's not a problem showing you 10. I'm already logged in here as Jake. So here's Google. I want you to download the Chrome Remote Desktop. So go Google for Chrome Remote Desktop and install that. That is a plugin that will install. I've already got it installed, so I'm not going to go through the installation. But when you go to that page for the first time, you'll see. Actually, let me throw the server part away for a minute, just so that you can see the same thing I'm seeing. The first time you run Chrome and the first time you go to the Chrome Remote Desktop site, it's remotedesktop.google.com. You will see a screen that doesn't have all that other. It'll look like that. Okay. Set up remote access. And you can do this on your workstations too if you want, but I want you to do this so that you can remotely view these virtual machines without having to use VPN. Okay. It runs faster, it runs better if you're not using VPN. It's just easier to use these tools. And another cool thing with Chrome Remote Desktop is you can remotely view your computers from your cell phone and drag your finger around as if it's the mouse. I love that. Being able to control your computer screen from your cell phone. You can be sitting on a beach in Mexico and realize, oh crap, I forgot to push a button to start a backup procedure or something. Let me go log into my server remotely because I've been smart and I install Chrome Remote Desktop on all my servers. I log in, push a button and do whatever I need to do and then go back to drinking margaritas or whatever I was doing. So turn that on. Choose a name for your computer. It's going to default to the computer name, which in the case of all these virtual machines, it's going to be student VM 12345. You can rename it or you can call it whatever you want. I'm going to stick the word EI Lab in front of it just so that I know that, oh, this is a machine in my EI block. EI Lab, EI block. Maybe I should change the name of the lab to EI block. EI Lab, next. It's going to ask you for a PIN number. You can simply use your student ID or your driver's license or your telephone number, whatever you remember. This doesn't have to be that secure because you have to log in with your Chrome account already to any other computer that wants to remote view this computer. So I'm just going to use my faculty ID. It's just something I type in all the time. Uncheck that box. Do not check that box. That's a bad thing. We don't want extra software running on our virtual machine. Then go ahead and click Start. Now, the first time you do it, it's going to download an MSI program called Chrome Remote Desktop host.msi, and it's going to appear down here and ask you to click to run it because it's a code that it installs. Mine's already got it installed, so it's not reinstalling it. It's just revamping it. I'm not going to save that password there. Once it's installed, then let's wait a few seconds here. Once it's installed, it'll say this computer is configured to allow one or more clients without entering a PIN to it won't say without entering a PIN. It'll just say this computer is now available to view. Now, put that machine aside. Go fire up Google Chrome on your laptop. This is, I'm VPNing this right now. And also go to Chrome, go to search for Chrome Remote Desktop. remotedesktop.google.com. That'll work. Go to that on your laptop computer. Do the same thing, except you don't need to set up remote access for this computer. What you will see instead is you'll see, and I've got a bunch in my list, you'll only have one in your list, you will see, where is it? There it is. You'll see that on this list. It may ask you, there may be a little pop-up in the corner that says, hey, do you want me to install this little helper program? Yes or no, thanks. You don't need it, but it'll help make the experience better. So go ahead and install the little helper viewing program. Watch this. I'm going to click on that. It asks me for the PIN number, which I just set up on that other machine. I'm going to click remember so I don't have to type it again. Again, I had to be logged in as my Chrome user over here. I'm not going to say that. And now, check this out. Now I am remotely viewing. I'm going to actually pull that one out and minimize that. I am now remotely viewing this computer over here from Chrome, which is kind of weird. I'm actually remotely viewing it twice. Oops. You know what happens in Windows when you do that? It moves things off the screen. Where did it go? There it is. So I'm actually remote viewing it two different ways. Isn't that weird? It's a little freaky. But once you do this, then you don't really need to use the VPN. In fact, I could kill the VPN right now. This screen's going to die. I'm sorry. I hate that. I know you can turn that off, but I hate that little wiggle thing. This screen's going to die and go away as soon as I kill the VPN, but this one will stay here. Where's my VPN? Where are my connections? I'm going to go back to my network connections. There's my VPN. It's connected because it's not saying disconnected. I'm going to click on it. I'm going to disconnect from it. Okay, so now I'm not connected via VPN. And the way I can tell that is I can open a command. I can try to ping the, I'll try to ping the domain controller again. Whoops, I can't ping it. I'm no longer on the domain network. I can try to go to IP. I'll go to IPmonkey this time, ipmonkey.com. Now I get a totally different IP address, your local address. This won't function anymore. It might still be here, but I can't do anything in it. It's essentially dead. Oh no, can't do anything, but I can still do stuff here. Still fire up Chrome over here, and that's because I'm running the Chrome Remote Desktop, which doesn't need VPN. The way it works is all the screen output in the keyboard output is sent to Google. They store it temporarily on a server, and then they share it back to your computer. So yeah, eventually the Zen desktop went away. It said, I'm dead, bye-bye. So I'd like everybody to be able to do this. And also, let's do the trace route again real quick. Let's see how that changed. Oh, by the way, if it ever does do that, press the Control-Alt-Delete. Chrome has their Control-Alt-Delete over here, that little arrow. And you can also, you can move it around in case you have to, by the way. Click that little arrow. There's their little menu of how to do stuff, like scale to fit, or resize to fit, or like I usually do use the scale to fit so that I can make it bigger or smaller. If you turn off the smooth scaling, it doesn't do it smoothly. In other words, you can warp the screen. But I need to do Control-Alt-Delete here so that I can log back in. because your virtual machine will occasionally log you out, or it'll time out and you'll go away, or you might accidentally. Now, if you log out here, you log off there, it's going to kill this connection because there's an application running in the background. Chrome Remote Desktop Host is running in the background. If you log off, that process stops running. You will lose your ability to see this window remotely. So finish whatever you were doing. You can close Chrome, close all your little notes files or whatever you're doing, and then just close that window. Okay, don't disconnect. Don't log out. Certainly don't do a shutdown. And then, as I promised earlier, I was going to do this just to show you that the path, it actually might be the same path because this does something called split DNS, but the path would probably be different, especially if you were to traceroute something at U of H. If you typed in traceroute www.uh.edu, while you were not on VPN, it will take a rather circuitous route to get there. Now, mine's only 5 hops away because I'm here at U of H. Yours might take 8, 10, 12 hops. But on the VPN, it's going to put me in the EI lab, and the EI lab is logically closer to www.uh.edu. So I might see 4 or 3 hops instead. Okay, so why don't I go ahead and end the class there. 80 questions about about what I've showed you today and what I expect you to do for the weekend. And do you guys think this is cool? I think this is cool. I think it's one of the coolest things that you can do with networking is remotely view stuff. Hang on 1 second for me. So here, I'm just going to show you this really quick. I'm going to log in to one of my servers from the remote desktop screen of my cell phone. Here, I'll log into that student VM that I just set up. Typing in that code. And I can literally log into, can you see that? I must not have the, I don't have the, there's the Windows. Usually I view it in landscape mode, but I don't have the auto switching on right now, kind of on purpose. But see, I can click on my start button with my finger and run programs. Isn't that neat? I think it's neat. Yeah, I got a nice ooh from co-op. So if you guys can accomplish that, that'll make you more valuable, more powerful, and you can show your friends how to do this, and you can save the day a lot of times. If you become a network manager somewhere and you go install Chrome Remote Desktop on a lot of the servers, even if VPN breaks, it does break often because you're relying on coding in another device somewhere on your network, and also VPN is complicated. It can be messed up easily. There's a bunch of different protocols and a bunch of different encoding schemes, and it's actually slower too. If that's not available, the only way you can get to servers is either physically go there or remote view them. So I put remote desktop on all of my servers. I make sure that the Chrome account that I'm using is a very secure account, and I've got two-way authentication and it's set up. And if anytime I log in to Chrome from a new computer, it sends me a text on my phone, so that if I get a text that, hey, somebody from Romania just logged into your Chrome account, is that you? I can say, no, that's not me, and I can kick them off. And then I'll go change my password or go do whatever I need to do. So that's saved me a lot because I've been able to remotely log into a server, even if I just needed to reboot it. A lot of times you can fix problems on networks simply by rebooting your server or rebooting your workstation. That's the first thing I tell people. Well, have you rebooted yet? That fixes 99% of problems. Okay, so let me end the class. I will send out an email a little bit later. It's probably not going to be tonight. It probably will be tomorrow, where I will have set up the Windows 10 virtual machine catalog for everybody, because I'm doing this for 4477 as well. And I'll have everybody's student ID and password set up. I'll probably just use a generic password for everybody, but I'll send it in an email to you. And then once you get that email, that will tell you, okay, now's the time where, and I want you to do this before Monday's class. I may have a class tomorrow. Like I said, sometimes I do stuff on Friday. So I may, if I have time, I'll do a little session tomorrow and we'll try this. If anybody wants a little more hand holding, but I want you to try it on your own. So when you get the email, that'll tell you, okay, let me go try to set up VPN on my machine, my Windows machine or my Mac. And let me know, for those of you that are using a Mac, let me know if you're running into some significant issues, or you realized, hey, you didn't show us something that's important to do on a Mac, because I don't have Mac, so I don't know how they need to work. The business world is overwhelmingly a Windows world, not a Mac world. Then you can set up the VPN, set up your virtual machine, install Chrome, get a Chrome account, a Google account, set up Chrome as your default browser, set up Chrome Remote, set up Chrome Remote on your desktop computer, your laptop, not your virtual machine. Make sure you can communicate remotely over Chrome, not the XenDesktop, and then go turn off your VPN and make sure you can still continue to operate that way. If you can't, turn the VPN back on and go figure out what you did wrong. Okay, so that will be due by Monday's class. And again, I'll send out an email with specific instructions and I'll post this video so those that are not here can watch this and watch the walkthrough. Any questions or comments? The class gets more exciting than this even. We do even more interesting stuff, in my opinion. I'm kind of geeky, but at the same time, I'm doing stuff that that a lot of people, I think, would be amazed at, stuff that you didn't realize. Oh, I didn't know you could do that. Oh, that would have saved my ass a year ago when I had to access something. I had to take a 2-hour drive to somewhere to just reboot a freaking server. You know, that's what this remote access crap saves me, is driving all over the freaking universe, pressing Control-Alt-Delete on my client's servers. That's why you do this stuff. Okay, so see you guys maybe tomorrow, but definitely on Monday. Go Cougs.